This is Algebra 2, Unit 10, Lesson 2 on graphs and zeros of a polynomial. Now, by definition, a polynomial is a function consisting of terms that all have whole number powers. Okay, so all the powers are raised to whole numbers. In its most general form, a polynomial can be written like this. Now, don't let the notation throw you. When you write a polynomial, what do you write first? The highest exponent power, and then you go in descending order. All right, now look at your power here. Your highest exponent power is n. Well, the next one down would be n minus 1, and then n minus 2, x minus 3, minus 3 and 4, until we get down to just 1, and then add the constant value. Now notice this value right here, this would be the highest exponent, and then this one would be the highest coefficient. So this would be the leading coefficient on the value. So this is just the little n right here just means the coefficient on the highest power. That's all that means. The n isn't actually a value. It's just saying on what number exponent it's on. It's on the highest number exponent. This is the leading coefficient. All right. So basically what we need to know is a polynomial is written with the highest exponent first, descending order until we get down to the constant. So today what we're going to look at are quadratic and linear functions of the simplest polynomials. We will explore cubic, which are x to the third functions, and quartic, which are x to the fourth functions. And their highest powers are x to the third and x to the fourth as c. Okay, so let's take a look at what these look like. All right, so for each of the following cubic functions, sketch the graph and circle its x-intercepts. Okay, so I want to graph each one of these. Now each one of these is a cubic function, so it's going to be an odd function, so the ends are going to point in opposite directions, so we should expect that. All right, so let's reset our window on our table, or our window on our graph, so that we have from -5 to +5 for the x's, and from -20 to +20 for the y's. So -20 and then +20. All right, now let's put our graphs in here. I'm going to put all three of them in at once. So this is going to be x cubed whoops, forgot to go off there. Forward arrow first. Minus 3x squared minus 6x and then plus 8. There's the first one. The second one is 2x cubed minus 8x plus 9. And the third one is 2x cubed minus 12x squared plus 18x. So there are my three functions. I'm going to shut off the last two because we're just going to look at one at a time. I'll turn them back on in just a minute. So I'm going to go back here and turn this one off, press enter. I'm going to go up here and I'm going to turn this one off. So I'm just going to graph them one at a time. Okay, so I have my window set. I have my equations in. Let's see what this looks like. All right, so I graph the first function and I can see the end behavior is agreed. One end goes up and the other one end goes down, so that's true. All right, now let's graph this on our paper. So we have, here's my paper. All right, so this went up like this, and then it came around, and went down, and then came back up again like so. Okay. All right, how many x-intercepts does this have? Well, it actually has 3. One here, and one here. If we look at our table, right there, and right there. Actually at -2, at 1, and at 1, 2, 3, 4. So those are my 3 intercepts, or 3 zeros. So this one has 3 zeros, or 3 x-intercepts. Okay, so this cubic function has 3 zeros. Let's look at the second one. All right, so I'm going to turn this one off, and I'm going to turn this one back on. Enter, and graph it. Okay. Let's look what that one does. It goes up, and then it comes down, but it doesn't hit the x-axis on the positive side. All right, so when I sketch that, it's going to go up, and then come down, and then go up here again. So the end behavior is still the same, okay? But one goes up and one goes down. How many x-intercepts does this have? Well, this only has one. That has 1, 0 on the problem. Okay, so far a cubic can have 3 zeros, it can have 1 0. Let's look at this third one, see how many zeros this one has. All right, so I'm going to shut this one off and turn this one on and graph this one. Oh, look at that. How many zeros does this have? It goes up, and then it comes down, and just touches the graph and comes back up. So this one actually has 2 zeros, here and here. So let me sketch that. It came up, went down, just barely touched, and came back up. Okay, so my zeros are here and here. All right, now this 0 right here is called tangent to the x-axis because it touches it just in one place. Okay, so that is tangent to the x-axis. So this one actually has 2 zeros. So a cubic function can have 1, 2, or 3 real roots and can have how many turning points? Well, let's see. This one turns here and it turns here. It goes from increasing to decreasing and then from decreasing to increasing. This one also has 2 turning points. It goes up and then it comes down and turns and goes back up. This one goes up, comes down, and turns and goes back up. So just as with parabolas, there exists a tie between a cubic's factor and its x-intercepts. So since there are this is a raised to the third power, it can have at most 3 intercepts. Okay, so a cubic has at most 3 intercepts. But it could have 2 or 1. All right, so consider the cubic whose equation is y equals x cubed minus x squared minus 12x. Algebraically, determine the zeros of this function. All right, remember, if we're looking for the x-intercepts, we know that y is going to equal 0. So if I take this equation, x cubed minus x squared minus 12x is equal to 0, and I want to find the zeros. Basically, what I have to do is solve this for x. Now, remember, when we did quadratics, we factored, set the factors equal to 0, and solved. We do the same thing with cubics. We have to factor. Now, how do I factor this first? What's my GCF? Well, my GCF is going to be x. So this is going to be x squared minus x minus 12 equals 0. Does this factor more? Oh, yeah, it does. That double bubbles. So that gives me x and x. We know it's going to be plus and minus, and then factors of negative 12 to give you negative 1 is going to be negative 4 and positive 3. Set the factors equal to 0. Now remember, x is also a factor, so x is equal to 0, x plus 3 is equal to 0, and x minus 4 is equal to 0. So I factor, set the factors equal to 0, and solve. So x equals 0 is going to be one of my zeros. This one's going to be x equals negative 3, and this is going to be x equals 4. All right, so my 3 zeros are going to be at 0, negative 3, 1, 2, 3, and positive 4, 1, 2, 3, 4. Okay, so there are my 3 zeros, and the end behavior on the graph, we know it's going to point down and point up. So this is going to go, if we go put this in the function, it should come up and go through 3 and then down and then come back up. Let's see if it does. So if I go to y equals here, let me clear these out. And I have x cubed minus x squared cubed minus x squared and then minus 12x. And my window on this is going to be from negative 7 to positive 7 and from negative 25 to positive 25. So to sketch this, I should have zeros of negative 3, 7, and 4. Let's see if we do. Look at that. Negative 3, 0, positive 4. It went up, came down, came back up. All right, so let's sketch that. It went up, came back down through 0, and then came back up here. Okay, and you can see there's my zeros, 0 and 4. Those are my zeros that I had found algebraically. So basically, when you're finding the zeros, you set the equation equal to 0, factor it, and then those are going to be your zeros. Okay, let's try this one. The largest root of x cubed minus 9x squared plus 12x plus 22 equals 0 falls between what two consecutive integers? Okay, so since this is going to fall between two consecutive integers, this is probably not going to factor nicely. So I'm going to grab my calculator and look at what the graph looks like. Okay, so y equals x cubed minus 9x squared. Fix this. Oops, I'll just clear it out. X cubed minus 9x squared plus 12x, and then plus 22. And when it equals 0, we're looking for where it crosses the x-axis. All right, so there's my function. All right, so my largest 1, 2, 3, 4, 5, 6, my largest zeros right there is between 6 and 7. My other zeros are between 1, 2, 3, and 4. All right, and this one is probably at 1, negative 1. So the largest root falls between what two consecutive integers? It should be, from our graph here, we can see that it's going to be 6 and 7. So it's number 2. Okay, now let's look at a quartic function. Consider the quartic function y equals x to the fourth minus 5x squared plus 4. Algebraically, again, determine the x-intercepts of the function. X-intercepts is when y is equal to 0. So we have x to the fourth minus 5x squared plus 4 is equal to 0. Okay, we want to factor this. Now, this doesn't have a GCF, but it does have 3 terms, so it's probably going to be double bubble. So let's double bubble this. All right, how do we get x to the fourth? Well, that's x squared times x squared. What kind of signs is this going to have? Well, if it's plus here but minus here, it's going to be negative, negative. And the factors of 4 that add up to 5, negative 5, would be negative 4 and positive 1. Okay, do these factor more? Yes, they do. They're both difference of squares. So this one actually is going to be x plus 2 times x minus 2. And this one's going to be x plus 1 times x minus 1. Difference of squares equals 0. Set each factor equal to 0. And solve. So one of my zeros is going to be x equals negative 2, x equals positive 2, x equals negative 1, and x is equal to positive 1. So I'm going to have a 0 at negative 1, negative 2, positive 1, and positive 2. So if I want to verify my answer by sketching a graph of the function. Now, since this is a fourth power function, a quartic function, it is an even function. Which way is its end going to point? It's an even function. The end should be pointing up. So let's graph this and see what it looks like. All right, so we have y equals, clear this out, we have x to the fourth, raised to the fourth, forward arrow, minus 5x squared, plus 4, and set the window is from negative 5 to positive 5, and the y's are from negative 5 to 10. So negative 5, and then going up to 10, and then I graph this. Look at that. Negative 2, negative 1, positive 1, positive 2. So let me sketch my picture. It comes down like this. Whoops. And it hits the points. There we go. Down like this. Comes up like this. Hits it here. Goes down here. And then comes up like that. Okay, and notice the end behavior. Both ends point up. And my zeros are here, 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 and here. So there's the 4 zeros. Okay, let's save the last exercise for next class.